Today's standard, or today's learning target, I have written back here, it says estimate the area under a curve using rectangles and trapezoids. We started doing that a little bit yesterday with the airplane hangar problem. Most of you kind of broke things up into rectangles and tried to add the area of all that together. We're going to use rectangles and trapezoids to help us estimate the area underneath this curve. I'll teach you a couple different ways to do it. Okay, this is our first standard. You will need to use rectangles and trapezoids on your first quiz and not actually use integrals or antiderivatives, but we'll get to that eventually. Okay, a little bit of a tedious process, but it gets you to kind of understand what it is that we're actually finding. So, the first time that I'm going to estimate the area under this curve on that interval, I'm going to go ahead and use what I'm going to call left endpoints. Okay? So let me kind of explain what that means. So I'm only concerned with the area under the curve from 1 to 3. Alright, so if I do another quick sketch, 1, 2, 3, here's the graph. Basically I want to know the area under the curve from 1 to 3. Everybody clear with what we're doing here? Okay? But obviously that's not an exact shape, it's not a rectangle, it's not a triangle, it's not a quarter of a circle, it's not anything like that. So we're just going to estimate it to the best of our abilities. And for right now, I'm going to use left endpoints this time. And I'm going to use, I want to be a little bit exact, I'm going to use an interval of 0.5. Okay? So what that means is, I'm going to start at 1, okay, because that's my beginning x value that I'm interested in finding the area of, okay? And then I'm going to make sure I have marks every 0.5 units from 1 to 3. So there's 1, 1.5, 2, 2.5, 3, which I think your paper already has that, okay? Or maybe even, I have it broken down even into quarters. I do for you. Okay, but let's just say I'm going to use 0.5 as my interval right now. Okay, so I'm using left endpoints. I'm starting at 1. 1 is the furthest left. I'm going to draw up to the graph from 1. Okay, and then I'm going to go over until I hit the end of that 0.5 length interval. So in other words, until I get over here to 1.5. And I'm going to find the area of that rectangle right there. Okay? And then I'm going to use 1.5 as my next left endpoint on my next rectangle. So I'm going to start at 1.5. I'm going to go up until I hit the graph, hit the blue graph. Then I'm going to go over and down. Then at 2, I'm going to go up to the graph, over and down. And then at 2.5, I'm going to go up to the graph, over and down. I'm going to find the area of those 4 rectangles, and that will be my estimated area under the curve. Clearly you guys can see when I get that answer it will be what type of estimation? High. Yeah, a high estimation, an overestimation, because I'm finding the area of rectangles that end up being actually above the curve. So this will be an overestimation. Alright, but it's still an estimation. That's what our standard is. We're going to estimate the area under the curve using left endpoints, we're going to use right endpoints, we're going to use midpoints, okay, and we'll eventually even use trapezoids to estimate the area under this curve. Yeah, Jake?
Could you also, like, so you get that value,
yep,
and then you do it so it's like all 2 less, and then you add those together and divide it by 2.
Find the average of those 2.
Yeah.
That will usually get you very, very close, especially on a parabola. I think it might even give you the right answer for a parabola. For sure, because parabolas are just a little more symmetrical than some other kind of funky curves can be sometimes, but absolutely, yep. And also on this one, because the graph is constantly decreasing, so that way if you do left endpoints, you're getting an overestimate. All of them are over, and if you do right endpoints, all of them are under. Now, if the graph did this, Jake, if the graph went down and then started coming back up, that'd be a little different, because then not all the left endpoints would be overestimation, some would be underestimation. So it doesn't always work, but definitely with this one it does.
Okay.
Does that make sense?
Yeah.
Okay? So we need to find the area of each one of these rectangles. Alright, well, base times height, right? Okay, so this is 0.5 units across. All of these would be 0.5 units across. But we got to find the height of each one of those rectangles. What's the height of that first rectangle? Well, how do I determine what the height of that first rectangle is?
You look at the y-axis.
You look at the y value that it goes up to. And what if I didn't have things marked really, really nicely for you? How could you determine what that y value is? Couldn't you plug in a 1 for x into the function? Because isn't this point right here that it goes up to going to be the y value of this function when x is 1? So if I plug in a 1 for x, out comes a 10 for y. So this point is 1 comma 10 right here. So therefore I know the height of that rectangle there is 10. So 10 times a half is 5. So the area of that rectangle right there is 5. The next rectangle has a width of 0.5 and has a height of, well, that coordinate right here would be 1.5 comma, you probably can't quite tell, right? So that's where you will have to actually plug in 1.5 into the function. 1.5, 2.25.
4.375 is the area.
What'd you get for the height of the 8.75?
Yeah.
Okay.
Yep.
So this is 8.75 units high. So when you take 8.75 times 0.5, Derek, you said
375.
4.375. And I found the area of that rectangle. And then I'll find the area of the next rectangle. So that would be 2 comma 7, right? Yep. So that's 7 units high, 7 times 0.5, that would be 3.5. And then this coordinate right here would be 2.5 comma 11 minus 6.25. I think you need to go to, of course, yeah. I'm videoing it though, Nick. Yep. 6.25, 4.75.
3 point. Oh wait, what are you doing?
I know if I plug in 2.5 squared would be 6.25, so what's 11 minus 6.25?
Oh, that's what I forgot to do.
4.5.
Well,
I shall.
4.75.
It's 4.75.
Oh yeah. Dang, I was thinking 13.
And then half of that,
2.375.
2.375. So I found the area of each rectangle.
What was that one?
2.375 was that last one. And then I add all those areas together. I'll need some help there probably too.
15.25.
So my estimation was, one more time?
15.25.
Anybody else agree with that? Just so we got second confirmation on that. I'm sure he did it right, just to make sure.
15.25 is what I got.
Okay. So, we estimate the area under this curve to be 15.25 if this is what we're using to help us find our estimation. We know that's too high, but what we did was we used rectangles, we used the left endpoints, and we used an interval of 0.5. Okay? How could you be more accurate? We talked a little bit about it yesterday. Make your intervals smaller. You could make them 0.25. You could make them 0.1. You could make the intervals really, really, really small. Alright? I'm not going to make the intervals ridiculous on your quiz. They'll be probably either 0.5s or 0.25s, or maybe even I'll make the intervals 1 if it's a wider range. Like if you got to go from 3 to 9 or something, that would be ridiculous to do 0.25s. You'd be doing the math forever on that, okay? I'll probably keep it to about, 4 to 6 rectangles that you're having to add the areas together, so it shouldn't take you too long as far as time is concerned, okay? But, so our estimated area under this curve is 15.25 when this is what I was using, okay? What questions do you have on that? And I'll do one more.
No label for that?
We'll go, thank you, we'll go just units squared. Unless it's a story problem, if we just ask for the area underneath the curve, I would just go ahead and write units squared. Yes. Okay, good. Any other questions? Okay. And I have a lot more copies of these. Everyone's, I'm sure, going to end up doing, 2 or 3 of them. But next, why don't we use, I'll kind of show you what right endpoints would look like. I think I'll let you do that on your own. Then I'll do midpoints, and I'll do trapezoids. Okay? Alright, so if I was going to use right endpoints, and still an interval of 0.5, I would not actually start at 1 and go up. I could start at 3, that would be one way to do it. In fact, that maybe makes a little more sense. I wasn't going to do it that way. I was going to start just at the right end of that first 0.5 interval. So I was going to start at 1.5. And then from there I was going to go up and over and back down. But if you wanted to, sure, start at 3, go over and down, 2.5, go up, over, and back down, and then 2, go up, over, and back down, and we did that first one again. Okay? And then you would find the areas of all 4 of those rectangles. Some of those areas, as you can probably tell, are going to be the exact same area as the ones you already did for the left endpoints. Some will be different, but some of them definitely towards the middle will be the same. Find the area of those 4 rectangles. Okay? And clearly, what's right endpoint's going to do for you? Give you an underestimation, right? Okay, that'll give you an underestimation. Just to speed up the process here a little bit, I know I'm going to give you guys time to do that, but let me show you what midpoints would do in this case. So if I'm going to do midpoints, but I'm still using 0.5 as my interval, so this is still where I'm interested, that's my 0.5 interval right there from 1 to 1.5, but I actually am going to use, in the middle of that, in the middle of 1 and 1.5, so really at 1.25, I would go up, and then from there, I'm going to go over, and then down.
See if we could do it in the middle of 2 points.
So my next interval is from 1.5 to 2. I'm going to go right in the middle of that. I'm going to go up to the graph, and then wherever it hits the graph, I'm going to go over to my left, over to my right, and back down. Now you'll notice on this one, midpoints is probably going to get us pretty close to accurate, right? Or a little closer, because it's doing a little extra here, but it's doing a little less here. So we'll probably get even closer yet. Do you guys understand what I'm doing there with the midpoints? Okay, and you'll get a chance to work on it yourself. All right? And then I want to show you trapezoids. Anybody remember the formula for area of trapezoid?
Base times height divided
Base
by
1 plus base.
2 divided by.
No way. Yeah.
Yep. It's on that A over there that you guys were complaining about the other day. Okay? That's the area formula for a trapezoid. And here's how trapezoids would work. So again, let's say I'm using 0.5s as my intervals here. So at 1.5 I'd go up. At 1 I'd go up, and I'd actually draw a straight line from where that point is to where that point is. And there you have a trapezoid. Everybody see it? That is a trapezoid where these are your bases and that is your height. That all right? And again, you know, once you guys start figuring out the y values at all these points, this goes pretty fast because that usually takes the longest time. But so in this instance right here, that base was 10, this base was 8.75, and my height is 0.5. So B1 plus B2, add those together, take it times the height, take it times a half, that would be the area of that trapezoid. Then find the area of that trapezoid. Then find the area of that trapezoid. And lastly, find the area of that trapezoid. And you'll notice how that gets you fairly close to an accurate answer as well. Okay? Probably a little more close than rectangles are going to.
It would underestimate it though a little bit.
It would underestimate it a little bit in this case because the function is always decreasing. You know, the function, if I had, you know, decrease and increase, and some would be underestimation, some would be overestimations. Okay? But so this was kind of, when you're finding area of some curved object, when you're first doing this, okay, there's no formulas for all this. So you had to just do your best estimation. And this is kind of how they started it. They started with rectangles, or rectangles and triangles, which really makes a trapezoid. And they broke it down to smaller and smaller intervals, and eventually we're going to get to the antiderivative and how that shows us the exact area under the curve, but we'll get to that later. Okay? So what I would like you guys to do, I think you can use these sheets here. We've done left endpoints, so I try right endpoints, and I'll get you extra sheets. I'll try midpoints, and I try trapezoids, and let's just see how we're doing, see what we're getting for answers here today. And at the end I will show you your first antiderivative, how to do it using one of the fundamental theorems of calculus. So, all right?
So
Okay, so time is yours to work. I'm going to stop the video here and I'll pass out some extra ones.